Hello, everyone. Hope you're having a great morning. I want to thank everyone for coming. And if you're across kind of broader Web3 ecosystem joining this movement, I think this is something that's at the core of the spirit in Web3 of reclaiming your sovereignty, of controlling your assets, controlling your data, your own choice. And it's exciting to see this movement continues growing and we continue advancing this mission. So today, I want to talk about Near being a blockchain for AI. And I want to introduce kind of what we've been working on across the stack, and then we'll have dive in from Skidanov, Shevchenko, Kendall, and Bowen, talking about how different pieces of what we're working on fit together and really powering this extremely unique opportunity we are in right now. So first of all, I want to say huge congratulations to the protocol team and to this whole Near ecosystem for launching Nightshade 2.0. Let's give a... This is something that we set out to do back in 2018 to build a sharded blockchain that is able to continue scaling for any demand coming in, for billions of users, for trillions of transactions. And it took us some time. It took a lot of research. It took a lot of development. But Nightshade 2.0 was the biggest upgrade since mainnet, went without a hitch. We have not had any downtime in kind of in the network, and kind of the protocols continue upgrading. We just had another upgrade actually today, reducing gas usage, increasing throughput of the network. So it's amazing to see this progress, and I'm really excited to hear Bowen's talk with more details on that. Now, what this enabled, among other things, is to make Near the home for consumer crypto, right? Instead of paying massive fees, waiting for long transactions, instead of having unreliable network where you send a transaction and 30 seconds later it says block hash expired, you have something where users can onboard really easily and start using. They already have effectively a consumer experience that they're familiar with in case of Kai and Sweat, and are able to use this extremely easy, right? And we have, especially I want to call out Kai, which had 250% growth in their user base since the year start. Hot launched this year and grew to 20 million plus users, 4 million monthly active. We have Sweat continue kind of innovating and progressing and kind of showing massive usages. Play Ember, we have Meteor, we have Sender, we have lots and lots of applications growing on Near, really providing this functionality across the board. Now, on the other side, Near ecosystem has been growing, and there's a lot of going on, but it's always not going to be enough. There's still lots and lots of interesting things happening across Web3. And this actually, for me personally, have been a very challenging state where you're like, oh, should we try to pool the projects to Near, and should we try to convince them, and kind of enters this effectively like zero-sum game, or should we actually make it easy for everyone to work together, right? And so, kind of through a few iterations, right? Originally, it was blockchain operating system. We introduced chain abstraction, really allowing to interconnect all of the applications on all of the chains together in a seamless experience. There's a ton of work happening. Again, Kendall will dive into this. We had a chain abstraction incubator launching, which is an amazing project building on this stack, enabling kind of next level of innovation here. Finally, this year, we've introduced user-owned AI. This is something that's very close to my heart. I've mentioned this many times. I've been thinking about AI since I was 10. I was trying to build first things when I was 14. I started working when I was 17 in a machine learning company because I was excited to do this. And I went to work for Google Research because I saw that there's an opportunity to do something with neural networks. And we started Near AI originally because we saw the technology is evolving and you can do really interesting things back in 17. Now, the challenge that continued kind of across all of this thinking has been that to really build this, you need to build a company. You need to build a centralized place which will collect more and more data and create kind of bigger and bigger kind of moat around it so you can make more money, so you can invest more in research and development, right? This is how Google done it. This is how OpenAI is doing it. This is how kind of even Facebook is doing it, even if they open source it. And this actually is counter to the reducted movement, the Web3, and in general what we're trying to do, right? How do we bring this into the hands of the users enable the users themselves to benefit from this technology and always be kind of in control. And so that's kind of the user-owned AI movement we introduced. And it's going to take a village. It's going to take a massive amount of work across the ecosystem to make it happen. So I kind of introduced a stack that we need to build. This is mimicking what's happening inside centralized companies and really building this kind of in open as an ecosystem, where you have a whole host of data and storage kind of providers, everything from indexing new data, crowdsourcing, monetizing various data stream, private computation over data, as well as decentralized data storage. You have an infrastructure and model layer where you have everything from training to inference to training specialized foundational models to agent frameworks and kind of agent payment layer. And obviously you have applications which actually benefiting from this in providing this benefit to the user. So we've been having a massive growth of this ecosystem this year. There's also obviously accelerator with Horizon, with Delphi, with BetterWorks. We have communities across San Francisco and globally. And so this has been kind of booming ecosystem of projects really pushing together what is possible and how we bring this user-owned AI forward. Now, I want to showcase kind of how this thing's already coming together. This is an example of BitPay Wallet, which allows you to effectively talk to different agents which can create transactions and interact on your behalf with the wallet and with other chains, right? So chain abstraction, AI, and scalable blockchain all coming together into one, really enabling this unique experience, right? For example, interacting through Safe on other chains on Ethereum. You can stake on Near. You can use Potluck through the natural language interface. And it's an extensible platform where people can build more agents and integrate them into this. And if you want to learn more, Nate is going to be talking and kind of showcasing how this works. So I mentioned user-owned AI, chain abstraction, sharded blockchain. So user-owned AI, chain abstraction, blockchain. Well, these are not three different things. This is one Near protocol that really enables this unique experience where you're interacting with computing is changing to be powered by AI. You have chain abstraction that effectively removes these boundaries between chains and between interactions and assets you're doing. And you have blockchain that can scale and power all of this in a robust way. Now, changing gears a little bit, why kind of the current world is not just kind of fundamentally broken because of incentives, but also product is not where it is, right, where we want it to be. First of all, if you're looking for doing some commerce, you're looking for some product or for some service, you have Google results, which are effectively spammed with ads, right? This is their business model. They effectively selling your attention to the highest bidder and allowing you kind of to guide you there. And you go to some random website, you need to go through a lot of clicks, you need to sign up. Now you don't know who did you give your data. You then enter a credit card. You hope it's actually a safe place to enter a credit card. And then you have to monitor email updates. Hopefully they deliver. There's unclear process of how to make sure this works. Now, AI introduced a new level, right? We can now effectively interact with computing in a natural way. We can talk to it. And the challenge is it lacks action, right? It can give you information, but I'm trying to buy a road bike. It gave me some options. I can maybe ask it to refine the search, but I still need to go and use Google, for example, to find actually where to buy it. Finally, blockchain has built the most efficient speculating engine, right? I mean, what we've seen with Polymarket is amazing because it's effectively a global speculation on elections, which was extremely effective. Now, the challenge is it is limited how much you can speculate in completely digital world if you don't connect with real economy, if you don't connect with real value-add services and products for mainstream consumers. And so far, the blockchains have been focused on effectively this zero-sum game, as I said, where they're trying to battle for existing users and developers, targeting them from one chain to another, kind of trying to rotate them, and with throwing massive incentives, right? So we don't have this like, how do we actually get out in the real world and bring real world to the blockchain? So as in blockchain for AI, we're trying to power this user on the internet, right? We're powering this kind of movement where you own your data, assets, and power of choice. And so to do that, we believe we need to change the paradigm. Again, the current paradigm is you're using search engine, which is using advertisement, you're using payment processors that, taking its own cut. You have effectively like a whole marketing machinery behind the scene that is trying to target you and kind of rewrite what you're actually looking for to target you to a specific product. You have obviously kind of algorithms in TikTok and Instagram and X, which are that are optimized for making money for those companies, not how benefit you, how to get your well-being. So the new paradigm is where AI is your interface with internet. It's your AI assistant that is able to understand what you want, understand kind of your needs, as well as plan long-term how to grow your net worth, how to benefit your overall well-being. And now this interface is able to directly connect with products and services around the world and on blockchain to actually have this direct relationship and find the best product, right? AI assistant doesn't care to look at the first few links in a Google search. It will look through tens of thousands of options and find the best one for you. And so this is kind of the new paradigm. And in this paradigm, you still need a middleware, right? You need still a connectivity tissue that will connect your AI on the front end with services, AI agents, smart contracts on the back end to really power this economy. And that's what Near is doing. Now, we're introducing a new concept. And this concept is intents. This is a new type of a transaction that allowing effectively anyone to come into agreement with other parties to exchange assets, goods, services, and it comes with a lot of different functions. So again, let's think back, what is missing from a blockchain right now? We have transactions, you can pay someone around the world for a fraction of a cent, but we don't have real commerce, we don't have real services, because there's terms of service, there's regulations, there is services sometimes don't get delivered, and or goods get lost. You need a way to ensure it, and you need a way to make sure to have some service provider to respond to you. And so all of this now comes into a new model where in the intent itself, you can attach effectively your information, you can sign the terms of service, you can have a dispute resolution, which includes insurance, which includes even potentially a contract effectively that will be used in court. And importantly, this works between users, their AI assistants, other AI agents, and regular services, like everything from a restaurant to a bank can be running this on this model and be able to provide services to the global world. Finally, this abstracts all of the kind of different technologies that we've been building around chains, tokens, agents, contracts, and really provides a single interface that is extremely easy to use. And you'll see more how this works right now from Alex Shevchenko. Now, to just give you a little bit of taste, what does this look like, right? Your AI assistant, as you wake up in the morning, it already predicts what you're going to do, what you want, and it in the morning reaches out to the newspaper and fetches effectively a set of headlines and their costs, right? Now, your AI agent decides that you will want to read summary of the first three, and it pays a little bit with a micropayment to the newspaper to receive them. It then summarizes it and gives you recommendations in your UI. Now you wake up, you click, you scroll through the feed. Again, this feed is prioritized for you to really kind of benefit your information based on what you want to know, based on what you're interested in. Now, you actually want to read one of the articles beyond the summary, and so you open it, and now your AI goes and requests the full article, and in this case, it's actually worth getting the, not paying for it, but actually getting the ad, right? And so now, using the trusted execution environment on the phone, there's actually an attestation that you have watched the ad as part of reading the article that is being paid effectively to the newspaper that it can cash out from the advertisement, right? So this is all effectively this intent flow that allows to exchange attestations and information and settle all of this on chain as the transaction concludes. Another example, this is something kind of close to my heart. When the war broke out in Ukraine, we have started a effectively crypto donation fund that was distributing funds and doing a lot of different efforts. And it was hundreds of volunteers effectively working like 20 hours a day to really coordinate, collect information, help with fundraising. And so you can imagine actually talking with your AI assistant saying, hey, I need to start, I want to start such an effort. And it actually helps by starting a number of other agents that are actually running in the background and executing different tasks. So you can have a fundraising agent, right, that actually reaches out and directly to people, explains to them the situation and how the efforts of this DAO specifically will be executed. It has another agent that is actually receiving information and requests from people in need and processes them, evaluates their as well attestations, for example, their location, their KYC. In Ukraine, there's a bank ID for that. And based on that, distributes small amounts of money. As well as it realizes there's requests from people that require actually shipping products that are not available in Ukraine. And so it goes and procures them in Germany, in Poland. This is actually what we were doing, sends them to the border, and then volunteers actually drive it through Ukraine. So this was coordinated by hundreds of people, but you can imagine a set of agents actually working on behalf, and there's still people who will be involved in validating some of the decisions, but a lot of this work actually can be effectively automated through this model. Finally, running a startup, one of the most painful things is filing taxes and finding the best provider. So you can imagine your AI assistant actually reaching out to Discovery Agent in this case, which gives you different options for what you're asking for. And from these options, you can select, it can give you more context, and it sends all of the accounting information to that agent specifically. Now, Alex Skidanov will talk more how we're doing privacy and how these agents can run in a specific and trusted execution environments to enable that. But what this means is even the developer of this agent is not actually receiving your accounting information. It always stays private and secure, and you're just getting back the filing. And you can maybe check with other agents as well to recheck this information. So all of this is the vision, but it's actually not that far. Today we're going to open up a Near AI assistant. It's available on chat.near.ai. It is an alpha. It is still, we'll continue iterating, but we wanted to open it up. We wanted to make it open source, and we wanted to open for people to start developing. The model and kind of the way it works is your AI assistant is effectively able to call other agents, kind of other functionality, and through that, you can continue permissionlessly expand what the AI assistant can do. So let me give you a quick example, right? So this is your AI assistant, chat.near.ai. And first of all, it has local memory about every user. It's able to associate it with a Near account. So it's able to actually remember things as you're talking to it and use that memory in different things. It is a generic kind of, chat assistant, so it can answer, questions like what is Bangkok famous for in normal way. But importantly, it also can do actions. Very similar to what I showed with Bite. For example, you can create a meme coin about frogs at a party, and it will go and generate not just an action, but actually generate a whole web page that you can deploy to a website. Right? So this is fully generated by AI. And obviously, you can edit it if you want. It can create the image, and it actually can go and deploy it to the meme launch platform that we have, Meme Cooking. Right, so this is fully done by an AI agent that is specifically designed for launching meme coins. And you can call it from your AI assistant. It detects kind of your intent to be creating a meme coin and routes it to this agent. So it takes a little bit of time to show up on the meme cooking platform. Now, you can always go and say something like, hey, make a meme coin with my favorite color, because it actually remembers what is your favorite color. Again, shared memory across all of the agents. And I think we should see it now. Yeah, so it showed up. So you can try this now yourself on chat.near.ai, log in with your Near account, create a meme coin. Let's make a few hundred meme coins right now. Now, the other example I mentioned, this is not just for Web3. So this is example, you want to do something with Web2 with proper commerce. So for example, you want to buy a Near t-shirt, right? So you go shop. What it does actually generates a UI on a fly because it knows you want not just a text interface, but actually a rich UI where you can look through different options. You want to select different sizes, and you want to effectively provide an address. What this does underneath, again, it works with a shopper agent that receives your information, sends it to the service that will be delivering you t-shirt, as well as helps you create a transaction to actually pay for it. So this is an example where it actually shows you that it calls the shopper agent kind of the first time. You can allow it to always do this. And it says, hey, it's going to execute a transaction on your behalf. Do you want to do this? And so this is kind of executing the payment. And all of that, as all of this is done, it actually ships that to order to the service that actually provides shipping for the t-shirts. So this is an example, again, of Web 2 and Web 3 working together from one AI interface. It's not just text, it's a rich interface that allows to have kind of rich interactions, and it's able to generate them on the fly for specific use cases, and you can kind of customize it for yourself, and it's able to remember how it works. There's a lot more work to be done, and again, this is an open platform. Anybody can come in and contribute, and you have a GitHub Near AI to contribute to the platform as well. So I will pass it now to Alex Skidanov, the co-founder of Near, as well as co-founder of Near AI, who has been working on the research side that's actually going to be powering the future of this technology.
How are you guys doing? Okay, let's talk about artificial intelligence. If you look back at the history of technology, if you look at what's been happening with search, social, mobile, it always begins by something new and exciting, something that changes our lives to the better, and then one or two companies fully capture the whole, attention, whole value from the new market, and then, a decade later, that market is entirely, used to capture every single dollar of our of value without producing value for users anymore. Right, so with search, if you go to Google today, it's almost impossible to find anything. With social, it's all optimized for your attention so that you spend, more and more time in there. And artificial intelligence is in a very similar space right now, in a very similar moment in history, where we are still at the moment where we're very excited about something new, but we already can see that, 1, 2, maybe 3 companies are fully capturing value. And that will create a data wheel that will effectively make it more and more hard for others to dethrone them in the future. And as long as, if you, like me, believe that AI will be a very big part of our interactions with the internet, with the world, with practically everything in the future, that means no user-owned internet, no user-centric future is possible as long as large language models are controlled by large corporations. And if you look at those large corporations, they have, like if you think of OpenAI, Anthropic, Google, Facebook, they have data, experiments, compute, the best researchers all in the same place, are all very nice centrally orchestrated. Right? So that allows them to iterate very quickly, while outside of them, if we wanted to replicate it in a decentralized fashion, first of all, we don't have access to resources that are of the same quality today. Second of all, even the resources that exist, they all spread out, right? So a person who tries to push it forward, they spend a lot of time, looking around, finding things that they need. And we want Near. Near is in a sort of unique position to try and go ahead and solve it, because relative to Web 2 companies, right, such as, like any Web 2 company that would try to dethrone, hypothetical OpenAI, we have years of experience of pulling resources together, of orchestrating large sets of people in a decentralized fashion, something that is absolutely impossible in Web 2. Sending micropayments, annotating data, etc. While relative to Web3 companies, Near is in a unique position because Near internally has a lot of experience building artificial intelligence. One and only of my co-founders is literally the creator of transformers, so it's nobody in the world is positioned better than Near to make this change, and so correspondingly, it is effectively our responsibility to drive this this innovation forward. And effectively, the way we want to do it, the way we're doing it today, is we want Near to be a central, decentralized place for all the things related to AI, so that all the data sources, all the models, all the experiments are discoverable agents, so that you have access to compute, you have access to data annotations in one place. And yet, each of those is coming from various ecosystem projects from different decentralized entities, right? And none of that, nobody disappearing tomorrow because they ran out of money or turned out to be, malicious from day one, affects in any way the whole effort. So before I get into the fun part, let's address the most important part of decentralized AI. The decentralized AI, one way or another, needs to be private. When you interact with ChatGPT, you know that your data goes to OpenAI, but at least you can assume that that OpenAI has at least some effort to protect the data. It's a bad place to be in, but it's not as bad as if you were using some decentralized AI servers where some random person is running a machine with the 8 H100s and your data just goes to them and they sell it to the lowest bidder, highest bidder. Interestingly, private AI is possible, and the way it is possible is all the modern CPUs and GPUs allow a technology called trusted execution environment, something Illia mentioned during his talk, which effectively says that if someone, let's say me, has a computer, and I'm a malicious actor, you should never trust me, and you have some computation you want to do, but you don't have access to compute, you can send it to me, and I can execute it in a trusted execution environment, and you will be absolutely certain that I had no idea what was happening on my computer. I could not see your data. I could not see the code you're executing. All I know that something was executed on my machine, right? And so that allows you to build all sorts of interesting use cases. It allows you to do private inference, meaning that I could be running a model on my machine, and you could come to me, run inference on my machine. I will not see your data. I will not see what you were doing with in there, right? You can send any medical records, any private data, and you will have 100% confidence that that was not in any way seen by me. It allows you to run agents. Like an agent provider says, this is my agent. It's open source. It's beautiful. It does everything you want. Here is the endpoint. There is no way for me, without trusted execution environments, to know that the endpoint I'm hitting is actually the agent that I see on GitHub. With trusted execution environment, I can do that. That allows you to have a network of agents running on a decentralized network where you know for every agent that it is doing exactly what is promised. You can use any secrets, private keys, everything, and be certain at every point that the system behaves exactly the way you want, and none of your data is going to any malicious or any other actors. But the most exciting thing that trusted execution environments unlock is that they allow us to create frontier open source large language models which are monetizable, right? So today, if you think about frontier AI, the models like Llama 405B or GPT-4 or GPT-5 is probably around the corner. They are massive. Training such a model requires hundreds of millions of dollars, and there are very few entities who can afford spending hundreds of millions of dollars to create such a model and then just drop the weights and say, hey guys, use it, it's all yours, right? And if the whole future of open source AI is fully in the hands of Meta, it's a very bleak future we have. And with TEEs, what you can do is you can pull together resources from people. You can train a model entirely inside of the TEEs using open source code, open source data pipelines, and then get the model that is open source, meaning that the source is open, but not open weights, meaning that the weights are not seen by anyone, and yet anyone can pull the encrypted weights to their machine and run it inside the TEE, but the TEE would only serve the model to you if you establish a payment channel and pay for the usage, right? And the price of the usage could be extremely competitive, right? So it could be competitive with any inference providers that exist today, but you know that the model, once it is trained, will be monetizable. Every usage of the model will be paid for, and therefore you can actually pull together those hundreds of millions of dollars and have those people have a reasonable way to expect to repay their contribution from the usage of the model. So that is extremely exciting because that technology actually gives us, a path towards the future in which the frontier models are created by the community for the community and served in a decentralized fashion without sacrificing economical viability. So that is probably the most exciting area that we are exploring right now. This is effectively the way, this is a little diagram which highlights what I was just describing, right? Bob, who you can clearly see is not a good guy, has a machine, and the machine is fully controlled by Bob, right? So like he can open it up, he can use a microscope to like inspect every little transistor in the processor, but there's a trusted execution environment within his machine, and everything that happens in the trusted execution environment, Alice can trust it, but most importantly, the protocol as a whole can trust it, right? So the protocol as a whole can know that the model, once deployed to any of the machines with the TEE, will not be used without proper payment back to the DAO that initially created it. So it's and payment channels obviously is something that we know works very well. There's a way to build this technology such that payment channels are open between the trusted execution environment and the user. So it's an exciting technology and exciting way forward for user-owned AI. The only problem is it's not enough to train a very large language model. Ideally, you want to train a large language model that is good, right? So for example, if you think about Llama 405B, Llama 405B in terms of size is comparable to GPT-4 or Claude 3.5, but in no way is Llama 405B competitive with those two models, right? So even Facebook, with all its resources, cannot train a model that is competitive with an OpenAI model. So how could we, without having access to researchers that Facebook has today, train a model that will be competitive? Because if the model is not competitive, you cannot monetize it. People will not use it, right? The way we approach it is we start a series of competitions where we're just going to bring all the researchers who today don't work for OpenAI, right? There are students all over the world who are getting into AI today. A lot of them are extremely talented and extremely knowledgeable who do not have a way to get access to compute, to get access to good data, to get access to other resources, and we will provide access to those researchers and a way for them to compete and show, that they are the best and they can contribute to the best model in existence. And you can think of it. Of course, we cannot have a competition. We cannot train a 1 trillion parameter model in such a way because even training one of them costs hundreds of millions of dollars. But you can train a small model, and you can begin with like a 500 million parameter model, which is small. And then you can have thousands of researchers simultaneously competing for training the best 500 million parameter model. And then you take the best of them, those who show that they are promising and can do exciting things, and all of them go to the next step. And now we train the best 2 billion parameter model, right? And then the best of those advance further. And at each step, you have fewer people, but those are the best people. And but you need more compute. Fewer people, more compute, it's the same amount of resources you need to spend until you get the very best, 10 to 20 people working on the very large language model that will be competing with the GPT-4s and Claudes of the world. And that's an exciting way to enable, first of all, to enable people who are very talented but don't have a way to work for those large companies, either because of their because of lack of opportunity or because of their values, right? Not every person wants to contribute to the evil corp, to get more and more of user data and user attention. So for many of them, that will be the way to apply their talent to show what they can do to contribute to open source AI and to get rewarded for that. Cool. So the first competition is starting effectively now. That will be a competition to train a very small 500 million parameter model. So let's together train the small one. And then we have a plan. We will publish it very soon. Effectively, in like 6-7 steps, we will get to to very large numbers, which are way more than half a billion, 400 billion to a trillion, etc. So everything I was talking about today, a lot of it is live at app.near.ai. It's a hub for all things AI, data sets, models, compute. It's a place where the competitions will be hosted. So the future of decentralized AI has never been brighter. So yeah, let's build the future together.
Hello, everybody. I'm going to talk about intents for agent cooperation. And in order to start, I want to share with you one quote of a person that really changed all of our lives, Albert Einstein. So he said that there will be trillions of AI agents, and maybe one of them could win the next US elections against Elon Musk. And obviously this is a joke, because Einstein knew that Elon Musk was not born in US, so he cannot run for presidency, right? But in every joke there is a grain of truth. And the grain of truth here is that there will be trillions of AI agents. Just count it by yourself. There are billions of people, there are hundreds of millions of corporations, and they have at least 10 to 100 services inside of all of these corporations. We are going to hit this number. This is the decentralization of the AI agents that we are going to face. And the question is how they are able to cooperate. And there are multiple stages of the cooperation for the AI agents that are in place. They need to discover each other. They need to figure out that some AI agents are specialized in ordering a coffee, and others are specialized in closing your banking account. They need to figure out how to settle in between them, and this means that they need to figure out how to pay, how they can be accountable for what they are promising to each other. Payment channels is another interesting thing. So everybody have heard multiple years ago about microtransactions and stuff like that. It was never picked up with people, just because for people it's not very convenient to use microtransactions. But for AI agents, as long as they have the access to compute, well, they can microtransact with each other. And the most convenient way how to do this is through the payment channels. And in the end, obviously, in case something is not working, we probably all have seen how large language models are not given to us what we expect them to give to us. There needs to be a dispute resolution mechanisms. It can be automatic on-chain, or it can be outside of the chain with experts coming in and figuring out how to settle. Now, the thing that we are bringing today is that all of these things are going to be available as a core part of the NEAR protocol. And this is our vision for the future of the infrastructure for AI agents cooperations. Now, a little bit into this vision, the decentralized message bus that is going to work in parallel with the NEAR blockchain itself is going to power the communication and discovery of the AI agents. As Illia said, we're going to introduce a new type of action in the NEAR protocol specifically for recording and settlement of the commitments. And the third thing is that we're going to open up, we're going to create a new standard for payment channels that are going to settle on top of the blockchain. And already many people have been talking a little bit about the payment channels, so just want to throw in something into you so you understand it a little bit more. So the payment channel is a construct that allows two agents to create a channel as a transaction on the network, on the blockchain. So this is like an opening transaction, and then they can send money to each other many different times, or many times, and then only settle on blockchain with another closing of the payment channel transaction, right? So that's the thing that is going to be introduced. And obviously you're going to say to me, yeah, the vision for the future infrastructure, yeah, very interesting, Alex, as always, but this is not the thing. This is the piece that I'm delivering to you on the vision side. But if you know me, I always try to ship something and give something into your hands so you can try it right here, right now. And the first use case for the intents on NEAR protocol is something that you are able to use right here, right now, and this is Multichain DEX. So, kind of not very funny, right? But actually it is fun. I will encourage you to check it out. But before we're going to take a look at the demo, I would like to pay your attention to 4 abstractions that are introduced in this product. First one is obviously chain abstraction. The tokens, the chains that this DEX is integrated, it's not only a single chain, right? Near, Bitcoin, Ethereum, Arbitrum, and Base are integrated right now, and more chains to come. We do have a wallet abstraction in this solution, so that it doesn't matter with which wallet you're going to sign in. Currently, we support Near wallets, all of the Near wallets that support message sign-in, and also Ethereum wallets, including MetaMask, Coinbase wallet, Wallet Connect wallets, and all this. All of this stuff is there. The third thing is a token abstraction. Everybody are tired of USDC on Base, USDC on Ethereum. There is only one USDC in the platform. There is only one USDT on the platform. There is only one ETH. So it feels like a centralized exchange. And the last and the most important is that there is a contract abstraction. Users are not calling any contracts. Users are not signing transactions that they don't understand. There is no blind signing that is happening there that causes lots of problems, especially in cases when the supply chain of the front end is compromised. So let's see it in action. You're going to app.nearintents.org, and you're able to connect to it with MetaMask directly. By the way, everything that works here is going on the Near protocol, right? So I'm choosing the deposit token, and this is Tether from the Ethereum blockchain. I'm copying the deposit address, going to my MetaMask, and I'm just sending Tether to this address exactly the same way how you have been sending tokens to your centralized exchanges of the choice. The deposit is received, and now you're able to do the swapping. Swaps are happening in between USDT and USDC. Please know that there is no particular chains that are connected with it. And you're able to withdraw USDC, in this case, in Base. You put in your wallet address, and you sign a message. You're not signing a transaction. This is just a message that you have signed, and it's settled on Near protocol. And if you will check it out, there is this USDC available on your account. With the rest of USDT, we're going to do something that is even more crazy. We're going to swap it into Bitcoin directly. You're again going to sign a message for doing the swap, and you're going to withdraw this Bitcoin into the Bitcoin blockchain by again signing a message. And just like that, Satoshi got approximately $50 worth of Bitcoin into his account. What you have just seen is a reference implementation for the intent protocol. It is not intended to be the place where you can go, though you can do it right here, right now. But this is something that we see that is going to be incorporated in all of the wallets, in all of the front ends that have users. This is not kind of a final product, but instead this is a platform that everyone is able to use in order to give this solution to the users. Now there are more things that are going to be developed within the Near intent paradigm. Obviously, the first things that we're going to focus on is adding off-chain services and AI agents for this. So a little bit of a different types of intents rather than just swapping one token into another, right? There will be new chains that are added, and these lays inside of the direction of the chain abstraction. So the first chains that are going to be added, and we're targeting for Ton and Solana to be added by the end of the year, and even more chains are going to be added. Because of the unique position of the chain abstraction narrative in Near protocol, we are able to do everything that you have seen with the chains that do not have any smart contracts. And to my best knowledge, this type of swapping in a permissionless manner is the first in the industry. We are going to integrate all of this with applications and market makers and solvers right away. Again, we are not keeping this inside, but instead this is an open platform, this is an open protocol for everyone. So if you would like to see this on your website, just get in touch with me and we'll figure out how to do this. We're going to help you to integrate all of this solution. Just in the realm of AI-Fi, we are going to add additional pieces of this financial infrastructure into this platform, including account-Fi, or the ability to trade accounts, lend accounts to other people. We are going to introduce a shared liquidity pool against which the market makers will be able to borrow, which is going to make the swaps even more efficient. Lending is going to be introduced, and more of the other primitives. As I said already a couple of times, the platform is open, and anyone is able to introduce their own types of intents that they would like to be available for everybody and for the front ends to use. And lastly, all of this is working as smart contracts on Near right now, but as I was saying, we would like to integrate it deeper on the protocol level to make it even more efficient and as a standard for everybody. Intents power the future of Near as the blockchain for AI, and I'm super excited that we're building this thing all together with all of the community. You're able to access it right here, right now, with your Near or MetaMask wallets. You can forget already today about using your centralized exchange for swapping this USDT into Bitcoin. Instead, you can do it directly on the Near protocol in a decentralized manner. Go and check out nearintents.org.
So what's really fun about working in Near right now is that everything we're building here is not just for Near anymore. It's actually for every single chain, and as Illia pointed out, it actually goes even beyond Web3 in general, and we're going to be able to connect to really anything on the internet, and hopefully actually change a bit about how the internet works. But today we'll focus on what we're going to be able to bring to all these different chains that are out there and why we're super excited about it. And I think when it comes to really making AI agents work in crypto and solving a lot of the problems that we currently have, what's going to be really required is that each AI agent has unfettered access to the entirety of the crypto space. This includes every single crypto asset, this includes every single smart contract, and really every single piece of state. This is part of the reason that we've been so focused on this concept of chain abstraction. It really is to make it so that developers and users are able to interact with every piece of state, every asset, everything on every single chain as seamlessly as possible. The way that we're making this work is using the Near abstraction stack. So Alex just introduced a really important part of that stack, which is the intent layer. We also have two other really key pieces of technology. One is chain signatures, and the other is the Omni bridge. So to give you an example of how this can kind of work, you can imagine that a user first creates an intent, basically submits a request to this intent and solver network. Once the auction is kind of decided, once like a solver is sort of chosen either by the user or through a programmatic way, that fulfilled request will then turn into a signed payload that can be relayed to a destination chain. And that's using chain signatures. And then once that's complete, let's say that there was a Bitcoin transaction that landed, oftentimes there's going to need to be a settlement process that happens on the Near side. And this is where Near as a blockchain will need to have access to that finalized state transition on the Bitcoin blockchain. And this is going to be using the Omni bridge, which is effectively a wrapper over some different message passing layers or even light clients, depending on the chain, that will let the Near smart contract know that that state transition on a destination chain has finally landed. So the most important takeaway from the piece of technology that I'll focus the most on today, which is chain signatures, is that we now have enabled smart contracts to sign transactions. And this is a really interesting design space that we're seeing a lot of teams start to take advantage of. So here's a little bit about how it works. So you can imagine on the one side, we've got this Near account that's on the Near blockchain that will be originating some type of signature request. So it'll call right now this signer contract on the Near blockchain with a payload, a cryptographic payload to be signed, and then basically the address that it wants to use to sign that transaction. Then the real magic we have here is this network of multi-party computation nodes. You can basically imagine these as a large group of distributed entities that have one part of like a key share that can be combined to sign for a private key that none of these individual parties know. And the goal is to make this group as large as possible, eventually hopefully resembling the makeup of the near validator set. So this group will listen to requests that come in on that signer contract, and they will then take that request and sign it using a deterministic derivation function that will basically ensure that this near account is the only one who can originate and sign for this request. They'll then return that signature on the near blockchain, which creates a perfect audit log of request and then response, so you can verify that this was done correctly. And then finally, that transaction will be passed to a destination chain. And this is how you enable near smart contracts to sign transactions for Bitcoin and Dogecoin and Ton, Solana, any chain that comes up with, any of the thousands of chains that apparently are going to be launching over the next few years, you'll be able to use this technology. Right now, we have about 24 teams who are building across 3 major categories. The first one, and one I find particularly exciting, is Bitcoin. In 2024, we've really seen, I think, a resurgence of, a realization that Bitcoin is kind of the OG of crypto assets. For a variety of reasons, it's going to be extremely important to continue to utilize. But to date, it's actually been pretty difficult to build with Bitcoin in kind of a trust-minimized way. Fortunately, using chain signatures, we're able to enable teams to tackle some really exciting use cases. On the one side, we've got Bitcoin lending. It's surprisingly difficult if you have Bitcoin on the L1 to borrow against your Bitcoin. Step 1 is usually some type of bridge that has quite a bit of latency. We're going to be able to really remove this using chain signatures. Part 2, runes trading. You've probably heard a lot about this as a primitive. People are very excited about the ability to issue assets on Bitcoin. But to date, that experience has been very limited when it comes to actually trading these assets because the Bitcoin layer 1 itself is limited. And then we, of course, have several other use cases here, like restaking or building liquid stake tokens on top of these restaking platforms. And we have several teams who are tackling that challenge. To give you a little bit of an example of what this can look like from an experience perspective, this is actually a fork on testnet of the largest lending protocol on Near that's empowering this Bitcoin experience. So you can see here I've actually connected my Bitcoin account using Unisat to this lending protocol. And you can actually see like a testnet Bitcoin balance right there. I can then actually just decide to borrow against this Bitcoin balance after I've deposited into the protocol. You see here, I'm going to like supply a little bit of Bitcoin. And then this transaction request that pops up is actually from my Unisat wallet. Because thanks to this chain signature technology, we are able to let users bring their existing wallet, any Bitcoin wallet that they have their Bitcoin custodied in, and then they're able to basically interact with this protocol just by signing a message using that wallet. And this same pattern can be replicated across anything. So Bitcoin users are able to be met where they are in their Bitcoin wallet, but then get exposure to all of these different usage patterns and all of these different new experiences. The next category we have a lot of teams building in is, I think, particularly interesting because it really changes the way that you can reason about like how you're designing your protocol. And what we mean by that is you no longer have to think in terms of how you're going to deploy your protocol on one chain, then you deploy that same protocol on another chain, and then think about how maybe there's 2 different versions of your protocol interact with each other. You can actually design your protocol to be completely agnostic to the eventual chains that your users will be interacting with. To give some examples of how teams are using this, Alex already showed an example of the near intense layer, which is basically making it so that you can swap any asset between any chain. We have a couple of other teams who are working on similar products, like OmniLane and Thesis, who's building a margin-based spot protocol that will actually allow users to deposit any asset and leverage against it. We have teams building lending protocols, particularly targeting very popular but underutilized assets like an XRP or a Dogecoin or even a Bitcoin. And eventually, you will even be able to borrow against your entire portfolio of assets that might span across multiple chains and opening up an entirely new capital base. And then we, of course, have teams building in like the yield space, the restaking space that will allow you to restake any cryptographic asset across any chain. To show a little bit about how this could work, very similar to the example that Alex gave earlier, this is a team called OmniLane who's built cross-chain swaps that will enable you to swap between any two assets on any chain. You can see here I basically connected my MetaMask account, and then I'm just going to go through and swap from the Polygon testnet over to Base. And it works pretty similarly to the intents layer, where you'll basically find a solver who will fulfill this for you in just a matter of seconds. And this experience will be replicable across a variety of chains. And then last but not least, we have account abstraction. We have a lot of very exciting teams building in this space, particularly Bitsa on like the kind of AI agent-powered end user experience. We have one of the most used apps in crypto, if you're familiar with the Hot Wallet, which is built in Telegram. They've actually deployed 6 million chain signatures-powered wallets that can actually like custody assets across a variety of chains. And then we have teams like Sweat, who is one of the largest kind of mass market user apps and is now able to bring their 100 million user plus base across a variety of different blockchains and applications. And then tomorrow, you guys will be getting a very special announcement from a very exciting team who's building in this space as well. I think what's super exciting about like what Bitsa has been able to do is that they can take a new design pattern, like a passkey-based wallet, and they can let you create a unified balance across a variety of different chains. So like you can see here that I'm actually have some Ethereum on a few different chains in my Bitsa wallet. And I can actually go and I can just connect my Bitsa wallet to Uniswap or any other application that supports Wallet Connect, and I can suddenly send transactions from that application. So you can see here I'm actually like sending this Uniswap swap, approving it on the Bitsa side. I'll actually sign using my passkey on my Mac, and then I've completed this transaction. You can see I now swapped from some Ethereum on Base to some USDC on a different chain. And of course, you can do this through the AI agent platform as well. So those are three of the areas we see a lot of teams building in. I think a really cool direction that we're going to be able to go that's uniquely unlocked by this MPC technology is actually building truly unstoppable autonomous AI agents. So we had Alex Skidanov mention earlier how you're going to be able to basically receive a verified request from an LLM by using a trusted execution environment. That's a really exciting primitive that lets you interact with an AI model and know that you were served from the AI model you're aiming to interact with. But I think what's even more interesting is when you combine this with the key resiliency of the multi-party computation technology, you can actually have these agents that'll just live as long as the network lives. Everyone's really excited about the idea of, well, effectively enabling like a Skynet, but no one's really put together the pieces to actually empower this today. So like we see a lot of hype on Twitter right now about what is going to be able to be unlocked with these primitives, and I'm excited that we're actually going to be able to deliver this tech stack immediately. So you can imagine that you basically have that AI agent that will be like have most of its sort of information and state either living on the near blockchain or a variety of decentralized technologies. A user will then be able to prompt this agent. You'll see like a trusted execution environment where someone's running this model that'll basically return the response and then the proof of the response using the remote attestation. And then this response will be able to interact with the nearest smart contract to then sign something somewhere. And because this smart contract will be using this distributed MPC technology, what that means is that in order to take this agent offline, you have to take down the entirety of the network, which is going to be extremely difficult to do. So this is how we can unlock these kind of truly perpetual and autonomous AI agents, which we're very excited to see how people build with this.
Hey everyone, how are you guys doing? Yeah, so you have heard a lot of very exciting new stuff from the previous amazing speakers, and I'm going to talk about something that's already existent, but hopefully equally exciting. This is how we build the most scalable blockchain. So from the very beginning, Near started with this vision of building a fast, cheap protocol that can scale to meet the needs of billions of users, and now also AI agents. And the primary way we achieve this is through blockchain sharding. So blockchain sharding is basically this scaling approach that divides the global state of blockchain into shard states so that no validators in the network need to track the state of all the shards. And as a result, the network can scale with the number of shards it has. Oh, sorry. So back in 2019, we came up with this Nightshade design for a completely sharded blockchain. And before that, all the prior art on blockchain sharding pretty much is what we show on the left-hand side, which is that you have one beacon chain, and for each shard you have a shard chain, and there is some complex orchestration mechanism so that allows you to communicate between different shards. But it's actually very difficult to implement because when you have one blockchain per shard, then it can have its own forks. When you want to communicate between two shards, you need to think about which fork it's coming from and which fork it lands on and what happens if it gets reworked. All of those problems do have some solutions, but it requires very complex machinery to make it work. And one of the key innovations we did with Nightshade is that we say, well, instead of having that complexity, how about we just have one chain that rules them all? So this one chain that has blocks that contains chunks, which are shard blocks from each shard, and this greatly simplifies the design. And this is what we did back in 2019, the first version of Near white paper. It's designed for complete sharded blockchain and has this asynchronous execution environment. If you want to communicate between two different shards or doing cross-contract call, what happens is that it first gets executed on the source shard, and a receipt would be generated and sent to the destination shard. And the security relies on fraud proofs, and this is how you guarantee that no nodes need to track all the shards while still maintaining the security of the network. Now, 5 years later, we made a lot of progress on implementing the original Nightshade vision, but over the past year or so, we did a major overhaul to the Nightshade design by introducing stateless validation, and this is basically the foundation for the Nightshade 2.0 that we introduced this year. The reason for introducing stateless validation is threefold. So one is because in practice, it's actually very difficult to implement fraud proofs and to test them, make sure that they're bug-free. And there is a very good reason why in the optimistic rollout board, people are still struggling with deploying them into production. And two is that it actually significantly improved the single shard performance. This is because before, the biggest bottleneck we have on single shard performance was state access. And the reason why there was a problem was mostly because you have to do a lot of disk reads, and that really slows things down. So with this design, we actually make sure that the state is entirely held in memory. We achieve this by having this twofold approach, where on the chunk producer side, because we only need a few of them, they can run more expensive hardware, and as a result, they can hold the state of an entire shard in memory and produce chunks, execute chunks by having the state in memory. And then on the validator side, because they receive state witness, they don't actually keep any state locally, it's naturally the case that the state is held in memory when they execute the chunks. And as a result, because the validators don't need to hold any state locally, they don't need to run as expensive hardware. In fact, they can run pretty cheap hardware. And this gives rise to better decentralization, meaning that we can have a lot more validators on the network. And this is not just something that we designed and put into some kind of white paper. Actually, over the past year or so, the team worked very hard on implementing this, and we launched in August 2024. This is the biggest upgrade we did to mainnet since the original launch in October 2020. In terms of lines of code, probably like over 100,000 lines of code changed. This huge upgrade was done completely live and with zero downtime. So as a user, you probably didn't even know that this upgrade happened, and has to rely on us like telling the story that this thing actually happened to know that, well, the mainnet has been successfully upgraded to this whole new version. And now mainnet is fully sharded. Both state and transaction processing are sharded, meaning that no validators need to track the state of more than one shard. And today we have 6 shards on mainnet. So that's a pretty good state to be in. But in my opinion, that's just the beginning of a whole new era where we want to explore the limit of scalability. We truly don't know today where the limit lies, because in theory, the mainnet can scale with the number of shards. And not only that, we actually also want to build this interesting feature called dynamic resharding, where the number of shards on the network would dynamically adjust based on transaction load. What that means more concretely is that if you have one shard that becomes congested, let's say there's like a popular app launching there, then the system would detect that and knows that it should split that shard into 2 shards. And conversely, if you have 2 shards that are both idle or low usage, then it would merge them back into one. So let's imagine in this bright future where we have 100 shards, and each shard can do 10,000 transactions per second, and that would result in 1 million transactions per second, which is 86 billion transactions per day. It's, it's a huge number, and we do need that if you think about the bright future that Illia, Alex, and other speakers have talked about, where we have billions of users and agents, or maybe even trillions, transacting, settling intents, and payment channels. This requires unparalleled scalability that only Near can offer through this sharded approach. And it's not enough to just have that 1 million transactions per second or 86 billion transactions per day. You cannot settle all the billions of intents per day inside one single smart contract. That just would be too much for one single smart contract, which lives in one shard, to handle. So what we need is actually sharded smart contract, which allows us to fully leverage the power of Near's sharding, so that instead of it existing on one shard, it simultaneously exists on all shards of Near, so that basically, no matter how many shards Near has, the smart contract would be living on that many shards. This is possible by making the smart contract code global, meaning that every single shard has access to the smart contract code, and the state is actually stored under user account rather than today stored under the contract account, which then have to live in one shard. And this means that it can fully leverage Near's sharding approach and be much faster and also much more scalable, and allow for this non-blocking peer-to-peer or multi-party settlement, which is key to this future. We'll have like tons of agents transacting with each other. So that's great. I talked a lot about how Near is scalable, how we can make it more scalable, but we also wanted to make it even faster than today. So today, it's pretty decent. The block time is about 1 second, and time to finality is about 2 to 3 seconds. But to make a truly seamless experience for the users, we want to do better. And one of the primary ways we want to do this is through the separation of consensus and execution. That may sound very abstract. So what that means is that today, one of the problems we have is that when you need to execute something, you first need to wait for the consensus to create a block, and then you know what to execute. That's a problem because it means that the nodes are not constantly executing transactions or receipts. It has to wait. Rather, what we want to do is that we want to have consensus run as fast as possible, just all those transactions, and then separately, the executions try to catch up. This means that a node would be constantly executing transactions because it knows what to execute. It's already there, waiting for it to execute. This would allow for much better throughput, but also would support long-running transactions because now you don't need to have a state root update every single block. And because blocks are produced much more frequently, if you have these RPC nodes, just eagerly execute them as they get produced, you also get optimistic confirmation that's much faster than what we have today. And that is enough for most people. And then separately, we still have the finality guarantees that we have today. So that's also not the end of it. So if you actually think about it in a more concrete way, like what this kind of thing actually enables, so on the bottom, you can see what we have today. So let's say you have some transaction that missed the block production, let's say got in like 1 millisecond after the block's produced. Then it's kind of suboptimal because you have to wait for 1 full second until the next block gets produced. Rather, if we have this separation of consensus and execution, the consensus just constantly runs, you can produce blocks much faster, and let's say blocks are produced every 200 milliseconds, then even if you miss the block production, you know that it will get in 200 milliseconds later, which is 5x better than what we have today. And what's more interesting is that it allows for this long-running transactions that doesn't fit in in the limit of one block. So that is not possible today because we need to make sure that consensus can continue producing blocks and not get interrupted. So that there is a gas limit that essentially limits how much time each block can spend on execution. And in this new world, because you don't actually need to have the state root update going into the consensus for the next block, you can actually wait longer than one block or even 2 blocks to wait for some transaction to finish. And this is very interesting because it enables use cases that are not possible today. For example, we have Aurora running EVM interpreter as a smart contract, and Alex has come to me at least 100 times saying that, hey, like, how can we make sure that one transaction can fit more gas into it so that we can be fully compatible with Ethereum executing 30 million EVM gas in 1 year transactions. So this is basically the solution to that. And on top of that, still the use cases we support today, let's say ref swaps that takes 5 milliseconds, that's also readily available and also much faster. So this combined with what we already have with Nightshade 2.0, this leads to a very bright future where not only Near is hyper-scalable, but also extremely fast and very versatile. You can build all kinds of different applications, whether it's decentralized exchange that does some swaps, it's very fast to execute, or some long-running computation that takes seconds to execute.
First of all, I think it's really exciting because this is also, I come to Bowen as well very frequently, where it's like we need to make blockchain faster. And indeed, we are getting to really good throughput. We can put a lot, probably most of the applications in Web3, if not all applications in Web3 on Near, and we're still going to have a ton more capacity. But now we can actually run with the speed of internet, where the latency, indeed, every 100 milliseconds are felt by users, so we can actually accelerate that. So really exciting. So we have the sharded blockchain, which is, is scalable, it is reliable, and it's getting faster and faster. We have chain abstraction, as Kendall talked through it, that enables using all of this kind of different Web3 technologies being built around internet, as well as enabling really interesting things on Near itself. We have intents as a new primitive that allowing us to effectively coordinate different actors, agents, services, market makers, participants on the global internet in a very kind of interesting new ways and creates this new amazing experiences as he showed. And we have user on AI with AI assistant and the research that's going to advance what's possible with Web3. So all of these are really powering this future that we're envisioning. All of them are effectively enabling how we see that AI will be driving forward, how we're interacting with internet, how we're interacting with computing, how we're interacting with each other. And all of them are effectively core components of this vision, right? Again, you can think of them effectively as front-end and back-end. It gets a little bit mixed with chain abstraction, as kind of Kendall was talking about. It can both work on the wallet side, enabling new experiences, and on the back-end side, enabling you to marshal assets and kind of interconnect applications. Similarly, for intents, it can work between effectively any off-chain agents, be that in the UI or on a backend. Now, the kind of what we're going after, right? I think one of the interesting things in Web3, we're always competing with other blockchains, and the reality is that's not the competition. The competition is the current status quo. It's the internet where the ads are effectively dominating and the attention is driven to monetize. Every interaction, every click, there's a ton of ad framework and ecosystem that's working to effectively drive you to some decision that is not yours. And so that's really what we're replacing, right? This is the new type of commerce powered by AI. This is user-owned internet that is on your side. This is replacing effectively the whole kind of digital ads and marketing spent on those ads that is over $400 billion in a year in the budget. It's all the payment processor fees and all the aggregator commissions, right, which are now disaggregated because your AI can actually evaluate all the options in a neutral way without needing to have a mediator and a third party, a middleman to do this. And finally, all the financial services, right, as you saw, what we can do now with intents, this also can work with fiat, this can work with stocks, it can work with any asset in the world. So that's the future where we're going, right? This is over $1 trillion of business value a year that we're going to be capturing through building the system with all of the applications and kind of AI assistants in the ecosystem, as well as with all the services and smart contracts and applications being built in the ecosystem. So few key takeaways, right? So Near is a blockchain for AI. Go check out Near AI Assistant. Again, it's alpha, so there'll be quirks, but you can try launching meme coins, not financial advice. You can. There's also like more and more agents going to be added to actually enable more and more functionality. If you're a researcher or interested in kind of building agents as well, go to app.near.ai for Research Hub. There's a lot of kind of more and more resources being added there. And finally, explore Near Intents, both how it works right now, as well how you can integrate it into your application, enabling new experiences, or become part of the network, effectively providing services into this. So I'll just finish on this thought that Near has never been kind of a traditional blockchain with lots of promise and lots of marketing and slow delivery. We always focused on like delivering really interesting stuff and trying to figure out how to market it and how to explain it. The story of iterating on open web and kind of all of the ideas how we kind of position this has always been our story of we see the vision, but we're learning how to communicate. And so what we're doing here is really going after that vision that we kind of always had since 2018, 2019, to really re-enable the internet and be that kind of infrastructure that really interconnects what's possible and removes middlemen, removes the kind of predatory economy that's been built right now on the internet. And so I'm really excited. There's a lot more talks and a lot of folks building the ecosystem already in these primitives, as well as new primitives for the ecosystem. There's applications talking about how kind of amazing experience they can provide. So I hope you enjoy the conference. I hope everyone has a great time in Bangkok. Stay safe, and thank you.